Hi class, good afternoon. This is teacher Metza. How are you? I'm feeling great. So how was your studies? Very good. Today our lesson will be focusing on the effect of ion concentration on the products of electrolysis. Now what is this all about? Well, this is about the concentration of ions. Now this is very important because when we do aqueous solution, when we electrolyze in an aqueous solution, so there are certain rules that we have to abide in order for us to be able to predict what are the products that will be derived from that electrolysis. So that's the reason why we need to really understand the effects of ion concentration. You know, if you remember last week we talked about the position of ions in the electrochemical series. In normal case, the one that is positioned lowest or lower than the other will be selectively discharged. But then when the ion concentration comes into play, then it not necessarily means the lowest position ion will get selectively discharged. It can be the other way around. So it is very important that we understand this. But before we proceed further, there is vital information that you need to get hold of before we proceed further. Now this is just to be sure that you understand when our lesson progress, because I do receive some inquiries from students who ask me some fundamental questions which are practical and which are quite right, because this has been confusing for many students, not only a few but many students. So I don't want you to be in that situation. Therefore I would like to very much make sure that you get this right and understand this correctly. Now we are talking about the ion symbols. What do they really mean? Now take instance the cations. Now you will notice that it is written Na plus, or what we normally call sodium 1 positive, or magnesium 2 positive, or iron 2 plus, or aluminium 3 plus. Now what is all this Na plus, Mg2 plus, Fe2 plus, Al3 plus? What is this all symbolize? So offhand, many people will say, oh, it's all about the valence electrons. Na has 1 valence electron, Mg2 has 2 valence electrons, iron have 2 valence electron, aluminium have 3 valence electrons. So most of the time they talk about electrons. So it's all about electrons being transferred, being given off, or being received, and so on and so forth. But then when they look at the equation, that is where the puzzle starts to come in. So we are going to address that problem right now. So let's look at this figure. Do you remember or do you know what is this atom called? The one with 3 protons, 3 neutrons and 3 electrons? Well, the tip is 3. So 3 means element number 3, and element number 3 is lithium. Okay. So let's look at lithium. So lithium has 3 protons and 3 neutrons, and of course 3 electrons. So what really happened is, the nature of atoms, they like to be noble, so to speak. Like helium. Helium is having 2 proton and 2 neutron and 2 electron with 1 shell. Oh, they are happy. The so-called noble gas. Likewise, lithium happens to have 1 extra electron, and it has to have another ring, another shell. So lithium too would like to be like helium, So in all likelihood, lithium will give off its electron to some other atom. So now, the moment lithium gives off its electron, what happened? So lithium has only 2 electron now, just like helium, and having 1 shell, the other shell just disappeared. And so in this situation, lithium thinks it is now a noble gas. Is it a noble gas? Yes, it achieved the duplet status, having 2 electrons and having in 1 shell. Yeah, it appears like helium, but when you look closely, then you find that lithium ion still has 3 protons but 2 electrons. In other words, lithium has an excess of 1 proton relative to its electron. So that is the reason why lithium is given a symbol Li positive, 1 positive, and this is why we call lithium an ion. Lithium is not a noble gas, but lithium has become an ion instead, although it looks like helium. So now, when you look at the 1 plus here, it definitely shows that lithium has an excess of 1 proton. Where does this 1 proton come from? No, lithium did not add any proton to itself, but lithium has more proton now because it has given off 1 of the electron. So by losing 1 electron, lithium has excess of a proton. So instead of having 3 protons and 3 electrons, now lithium has 3 protons and 2 electrons. So that is the reason we say lithium has 1 plus. 1 plus here means 1 extra proton. This happened because lithium gives away its valence electron. The moment it gives away its valence electron, lithium has become an ion having a 1 plus charge. So definitely lithium is not a noble gas, right? Then, do you know what a positive means? 1 positive, one positive charge means? It simply means an extra proton. And this extra proton is not added, but this 1 extra proton happens because of losing of 1 electron. That is what positive charge, 1 positive means. Likewise, if you see anything with 2 plus, what does it mean? It means 2 extra proton. That ion has 2 extra protons. Did they add protons to this ion? No, they just have that extra proton because they have given off 2 electrons. So when they give off 2 electrons to some other atoms, then they become an ion with 2 extra protons. So I believe you will understand when you see aluminium 3 plus means aluminium has 3 extra proton by virtue of giving off 3 of its electron to some other element. So that is the whole thing. So you may look at 3 plus in the form of losing electron, or you may look at 3 plus as having 3 extra protons. So when you have 3 extra protons, definitely you need 3 electrons to become an atom back to its original form, right? So I would rather you see this as 3 plus as an ion having 3 extra proton. It's easy for you to comprehend, rather than looking at electron and electron, everything is plus plus plus, whereas electron we see is written as minus. But then when we look at this symbol, they have all the plus sign. So whenever you look at one positive plus sign, means it has 1 extra proton by virtue of losing an electron. If you look at Mg2 plus, meaning Mg2 plus have 2 extra protons by virtue of losing 2 of the electrons or giving away 2 electrons to someone else. Likewise, iron 2, same thing. Iron 2 also have 2 extra proton. It is not being added there, but by losing the 2 electrons, make them have excess of 2 protons. That is how things are. So I hope you are clear on this. So it's the same with the anions. So when you refer to the anions, you will look at fluorine, chlorine, oxygen, and nitrogen. So these are the common ions that we will get involved, right? So what is this negative sign means then? So let's have a look. Now this is an oxygen atom, and you know very well oxygen number 8 have 8 proton and 8 neutron. Of course it also has 8 electrons, right? 2 in the innermost and 6 on the outside. So this is an oxygen atom. Well, just like lithium, oxygen too wants to be kind of noble, sort of. So they like to have this 8 electrons to achieve the octet status. You remember? So what happened then? Well, they get the 2 electron from somewhere. Bingo! They have all 8 electrons. 2, 4, 6, 8. So they achieve the octet status. But are they did oxygen becomes a noble gas? Not at all. Oxygen has now become an oxygen ion, an oxide, where it is always in need or in excess of 2 protons. It is always in excess of 2 protons, simply because now oxygen has 10 electrons, but they still have 8 protons. So they have 2 proton less. So that is the reason why we write there O2 minus, 2 proton less. That's all it means. Well, you can say it has two extra proton, but does O2 minus stands for additional 2 electrons or less 2 protons? I would rather read it as less 2 protons. It makes my mind very much clearer. Don't you think so? So, 2 negative means less 2 protons. Just simple as that. I hope you're very clear on this. So if 1 negative means like fluorine or chlorine, 1 negative means less a proton or a proton less. Well, 3 negative means 3 protons less, like nitrogen ions, you know. So this is what the symbol all meant, right? So I hope this is very clear, and welcome to latemina.com. All the time and anytime with Teacher Mensa. We are here to assist you to make you understand chemistry in the simplest form. So, are you ready to proceed now? Let's do it. Another factor we have already done last week. We are talking about electrolysis. I've shown you this and that, but just to make sure you understand what electrolysis is all about. So, number 1, ionic compound is broken down into free flowing ions, right? Either in liquid or molten or aqueous. So what you can see here is a container with some electrolytes in the solution. This can be in molten form or it can be in aqueous. So just give an indication. The anion, you know, when electric current is passed through the electrode, the conducting electrodes, you know, when you place that into the solution, you have the electrodes, the anode and the cathode, and you have the external electrical power source. So the moment when electric current is passed through the electrodes, what will happen? The anion will gather at the positive anode. You know, anode is a positive electrode. So all the negative ion, the anion, which we call the anode ions, right? So we call it in short anion, meaning ion that go to the anodes. So anode ions, in other words, we call it anion. Yeah, will gather at the anode, which have a positive charge. While the cations will gather at the negative cathode. You can see here. So cathode being the electrode, the cathode electrode having a negative charge. So the cations are all having positive charge. Of course, the positive will get attracted to the negative, and likewise the negative will get attracted to the positive electrode. So this is how it is. So the anion will give off electrons and be discharged, while the cation will receive electrons and be discharged at the same time. So what will happen is this electron will travel from the anode to the external power source, right? So the moment the electron is given off by the anions, right, they all has discharged themselves, right, to become atoms, to form gas molecules most of the time, right? Now at the same time, the electron will flow through the cathode, right, and reach all the ions and discharge them all together. So when they receive all the electrons, they get themselves discharged and settle down at the base of the cathode, or some may still stick on the surface of the cathode. So this is what the electrolysis, the process of electrolysis is. So when electric current is passed through the electrodes, the anions will gather at the positive anode, while the cation will gather at the negative cathode. Then the anion will give off all the electrons and get themselves discharged, while at the cathode, the cations will receive electrons and be discharged at the same time. So that is what the whole thing is all about. So the cations are discharged to become atoms and form metal solids, right? So I think this is very much clearer, because when too much of writing in a diagram, something, it can be confusing, it can be, your eyes can be blurred. So I try to make it as simple as possible, as clear as possible. So electrolysis of an aqueous solution will involve the selective discharge of ions to form product. Remember, electrolysis of an aqueous solution will involve the selective discharge of ions to form products. What this really means is when you do electrolysis in an aqueous solution, selective discharge will take place of the ions. There are reasons for it. An aqueous solution will always contain more than two types of ion at each electrode. That is, ion from the ionic compound and ions from the water itself. That's the reason why we have they have two types of ion at each electrode. So you may have 4, you may even have 5, but at least there will be 2 at each electrode most of the time. So example, we take sodium chloride in water, right? So the ions from the sodium chloride, NaCl, when they are in molten form, in this case they are in aqueous form, the ions will be released, Na plus and Cl negative. So they'll be roaming in the solution. At the same time, the ions from the water will also react, or in fact the water itself will react in a form of partial ionization, where as we have seen last week, one hydrogen get knocked off, and form hydroxide, and another one will become hydrogen ions, right? So in this case, the same thing happens. So now if you can look at this, you can see now you have Na plus with chlorine negative, and you have hydrogen plus and OH negative. So you have 4 types of ion here. So when electricity is passed through the electrodes, ion will move to the respective electrodes. Now you look at chloride ions and hydroxide ions. Both are having a negative charge, so they will gather at the anode, whereas the sodium ion and the hydrogen ion, having positive charges each, will gather at the cathode. Now the issue here is which one of these will get discharged. Now you have 2 types of anion at the anode, the the chloride ions and the hydroxide ions, and you have 2 types of cations at the cathode, the sodium ion and the hydrogen ion. Which one of them will be selectively discharged? So this is the issue that we have to address whenever we do the aqueous electrolysis of an aqueous solution. Must always bear this in mind. Unlike a molten electrolysis in a molten solution is simple, straightforward. There is 2 compound, and once they have been melted, so the ions will move freely. So one will go here, the other will go the other electrode. So simple as that. But when it involves aqueous solution, now you get involved with water. So when you get involved with water, this is what you will get. You get the extra hydrogen and hydrogen oxide, hydroxide to play with. So this is where all your skills of predicting will come into place. So you must be able to predict which one and which one will get discharged, selectively discharged, which one will remain in the solution. So for you to remember all this, there is a list, what we call the electrochemical series. I think we have gone that last week, where these anions are listed in their reactivity level from top to bottom, right? So when you look at this, you know very well that the one that is at the lower side, lower than the other, will get selectively discharged. If you talk about potassium and sodium, of course sodium will get discharged. When you talk about calcium and aluminium, of course aluminium will get discharged. When you talk about zinc and tin, so obviously tin will get discharged. It's very straightforward, right? Between copper and silver, then silver will get discharged instead of copper, right? So now we have this sodium and we have this hydrogen. Now we have these two ions in our solution. So which one will be selectively discharged? And the rule says, the lower the position of ion listed in the electrochemical series, the easier it will be selectively discharged. That is the rule. So here we have sodium and hydrogen. Now look at the position of hydrogen in relative to sodium. Of course it is very much lower. So since hydrogen is hydrogen ion being positioned lower in the electrochemical series, it will then be discharged. Straightforward, right? So hydrogen will go off, and sodium ion being positioned higher in the electrochemical series will remain in the solution. Straightforward and simple, right? Because the position of cations in the electrochemical series will determine which ion will be discharged at the cathode. Straightforward. So the half equation, 2H plus in aqueous, when you receive two electrons at the cathode, they become hydrogen atoms. Hydrogen ions become hydrogen atoms when two of them meet together, so they form a molecule called hydrogen gas and they get released, right? So 2H plus, remember H plus means two extra protons. So when they have two extra protons, meaning they really lost two electrons. So when you give back the two electrons to them, so they become hydrogen atom and form a molecule, and off they go in the form of gas. Likewise, we have these anions. So the selective discharge of anions also depends on the rule. And if you recall, we have three. Number one, the position of the ion in the electrochemical series. B, number two, the concentration of the ions in the electrolytes. And C, type of electrodes. So all the three factors will play a part in deciding which ion get selectively discharged. So right now we talk about our chlorine and hydroxide, our chloride and hydroxide. So when we look at this table, obviously hydroxide is situated at the lowest, whereas chlorine in the middle. Of course, at a glance we can see, of course, hydroxide ion will be discharged. Well, in most cases, yes, right? But there are times when the opposite happens, right? Instead of hydroxide being a selective discharge, chlorine is being selectively discharged. Now, this is due to the concentration of ions in the electrolyte. So, if the concentration of sodium or chloride is very much higher than the hydroxide ion, then the chloride ions will be discharged instead. So same rule applies to bromide and iodide ions. So again, not only the selectively discharged ions is based strictly on the position of ions in the electrochemical series, but it also depends on the concentration of the ions in the electrolyte itself. So in this case, we refer to rule B, concentration of ions in the electrolytes. So the half equation will be 2Cl equals, at the anode, when they give off 2 electron, since they have 2 extra protons, so beg your pardon, they have 2 less protons. So when they have given off these 2 electrons, 2 chlorine ion giving off 2 electrons, so the chlorine form a molecule, what we call a chlorine gas, chlorine molecule, and given off as gas. This can happen, but on other cases, OH will be discharged to in the form of oxygen and water, but we will look into that later on. But here is just to emphasize that selective discharge of ion not only depends on the position of the ions in the electrochemical series, but it will also involve the concentration of the ions in the electrolyte itself, right? And of course, types of electrodes used. So that will come later. We'll discuss that later. So the OH will stay in the solution with the sodium ion to form sodium hydroxide, NaOH. So this normally is done in industrial basis, where we need to produce sodium hydroxide, to manufacture bleach. We need to do. We need the chlorine. We also need the what is the other gas? Hydrogen. So that we can manufacture some other product. As I have told you, hydrogen, they can be used to harden or to solidify vegetable oil, liquid oil. So when they hydrogenate the oil, they make it into what you call cheap men's butter, sort of, right? So we call it margarine. And likewise, you can do for paper manufacturing, we need sodium hydroxide, for making bleach, for making soap, and so on and so forth. So this is done on purpose for commercial benefit, right? So here is an experiment showing the effect of the position of ion in the electrochemical series, on the selective discharge of ions and the products of electrolysis of aqueous solution. So there are two things here showing the effect of position of ions in the electrochemical series on the selective discharge of ions and the products of the electrolysis of the aqueous solution itself. Right. So the aim of this experiment is to determine the effect of the ion position in the electrochemical series on the products of the electrolysis of A, aqueous copper 2 sulfate, and B, dilute sulfuric acid with carbon electrodes. So this is what we try to do to determine the effect of the ion position in the electrochemical series, and of course the product that they produce, right? And the problem statement here is, how does the position of ion in the electrochemical series affect the selective discharge of ions and the products at the carbon electrode. Yeah. And the hypothesis is when the position of the ion is lower in the electrochemical series, the ion will be selectively discharged. So that is the hypothesis, and we want to prove that the hypothesis is correct. And the variables, we have A, the manipulated variable, the position of the ions in the electrochemical series, and then B, we have the responding variable where ion discharge and the product of electrolysis and electrodes, and C, the control variable, that is the type of electrode we use. And in this experiment we're going to use carbon. And the apparatus, we will have the electrolytic cell with carbon electrodes, test tube, battery, ammeter, switch, connecting wire, contact clips, rheostat, as usual. And the materials, right? We only use a minute amount, that is 0.1 mole over cubic decimeter of aqueous copper 2 sulfate solution, and also 0.1 mole over cubic decimeter dilute sulfuric acid and wooden splint. Just a small amount, 0.1 over mole, 0.1 mole over per decimeter, cubic decimeter, small amount. And then the procedure, as usual, the apparatus and the electric circuit are set up as shown in figure 1. As you can see, the container with the electrodes, the cathode, the anode, the ammeter, the battery, the switch, and the solution itself, and then with the test tube covering, trapping some gas if there are any, or if there is any. The electrolytic cell is filled with 0.1 mole of 0.1 mole per decimeter per cubic decimeter of aqueous copper 2 sulfate solution until the solution covers the carbon electrodes like normal, right? Then the switch will be turned on to allow electricity to pass through the solution for about 10 minutes. Then changes at the electrodes are recorded, and gas collected, if any, in the test tube at each of the electrodes is tested using wooden splint. Either they glow or they pop. Then step 1 and to 5 are repeated using sulfuric dilute, sulfuric acid, 0.1 mole per cubic decimeter dilute sulfuric acid. So there are 2 experiments that we're going to do. So this is what we achieve. A, in the electrolysis of aqueous copper 2 sulfate solution, right? Number 1, there are 4 types of ion in aqueous copper 2 sulfate solution. Yeah, there are copper 2 ions, and the sulfate ions from the copper 2 sulfate, and the hydrogen ions and hydroxide ions from the partial ionization of water molecules, as you can see here. Here we have 4 types of ions. So what happened is the concentration of hydrogen ions and the hydroxide ions are much lower than the concentration of copper 2 ions and sulfuric ions. The concentration of hydrogen ions and hydroxide ions are much lower than the concentration of copper 2 ions and sulfate ions. So when electric current is passed through the aqueous copper 2 sulfate solution, the copper 2 ions and the hydrogen ion move towards the cathode, sulfate ions and hydroxide ions move towards the anode. Alright, that is very obvious if you look clearly. So what will happen is at the cathode and at the anode, copper 2 ions are selectively discharged because they are lower than hydrogen in the electrochemical series. So copper 2 ions accept electrons more readily to form copper atoms, whereas at the anode, hydroxide ions are selectively discharged because they are lower than the sulfate ions in the electrochemical series. So hydroxide ion releases electron more readily to form water and oxygen molecule. So here obviously the lower the position of the ion, the easier they will be selectively discharged, and in this case they are discharged accordingly. So the half equation at the cathode, so copper 2 ion, when they give off or when they receive their 2 electrons, so they get back their electrons, so now they are back to themselves as being copper atoms, right? So they settle down as a solid metal, whereas at the anode, 4OH or 4 hydroxide, in aqueous form, will yield 2 H2O, 2 water molecule in liquid, and plus 2 oxygen gas. This happen when they release or they just give back away the 4 electrons that they have taken earlier. So they just gave off these 4 electrons, so they are back to themselves. They are balanced. So you have 2 H2O molecule and an oxygen gas. So as more and more copper ions are discharged from the copper metal to form copper metal, the concentration of copper ion decreases. Now this causes the blue color of the solution to fade gradually. As you know, the initially the color is blue, but the more copper 2 ion has been discharged, so the lesser the color will fade. Right, it's very obvious. Then copper 2 sulfate solution gradually becomes more acidic because concentration of hydrogen is higher than the hydroxide ion, because hydroxide had just gone off into gas, so leaving hydrogen in the water, so they become more acidic. Yeah. So B, when we look at the electrolysis of the dilute sulfuric acid, there are hydrogen ions, sulfate ions and hydroxide ions in the dilute sulfuric acid. As you can see here, H2SO4 in aqueous will yield 2 hydrogen 2H plus in aqueous, and SO4 with 2 negative in aqueous. SO4 2 negative. Then of course the water molecule will be partially ionized, so we have the H plus and the OH negative in aqueous form. So when electric current is passed through, the hydrogen ion move towards the cathode, whereas the sulfate ions and hydroxyl ions move towards the anode. So what happens? So at the cathode and at the anode, let's see. Hydrogen ion gain electrons from the cathode to form a hydrogen atom. So then two hydrogen atoms bind together to form hydrogen molecule, and they just become gas and they are released. So they are discharged. While at the anode, hydroxide ions are selectively discharged because they are lower than the sulfate ions in the electrochemical series. So hydroxide ions release electrons more readily to form water and oxygen molecule. So what happens is hydrogen gas is given off at the cathode, while oxygen gas is given off at the anode, right? So that is the half equation. 2 hydrogen plus at the cathode receive 2 electrons and become hydrogen molecule, right? And hydrogen gas is given off, while at the anode 4OH, right, will give away their electrons to form or to yield 2 hydrogen 2 H2O and an oxygen molecule gas. Oxygen gas is given and given off in the at the anode. So the conclusion from this experiment: the ions that are lower in position in the electrochemical series are selectively discharged during electrolysis of aqueous copper 2 sulfate solution and dilute sulfuric acid. So if you refer to your textbook, maybe you have some other experiment showing some similar reaction, right? It's quite straightforward. What is important is you understand the principle of electrolysis using neutral or inert electrode, carbon or platinum, which will not react with the ion. And of course you need to use the external power source to suck and pull the electron to give back to its original owner, so to speak, so that they become atom by itself. So I guess if you go through this again over again, maybe a couple of times, you will get the picture, you will understand more effectively. Yeah. Then next week we will still be on the ion concentration, and then this time we're going to look what happens if the concentration of an ion is more than hydroxyl ions. So what will happen? Then we'll also look at the effect of electrodes. What happens if we use electrodes which are not inert, like copper, for instance? What happens? So these are the things that we need to understand. And then the following week we will discuss about the industrial uses of these metals and how electrolysis are being conducted in the factories to produce their stuff. Yeah. So there will be another knowledge. So for the time being, this is teacher Medza, wishing you a good weekend and hope to see you again. Till then, this is teacher Medza saying bye for now. See you. Thank you.